And welcome back. Okay, so in this video, we're going to be taking a look at an extremely important concept, which we call completing the square. Okay, because what we essentially do is we create a perfect square trinomial, which allows us to solve. Okay, and what's really nice about completing the square is we can solve any quadratic equation using this method. Okay, there's really only two go-tos to solve any quadratic equation. One of them is a quadratic formula, which we'll be taking a look at in the next video, and the other is completing the square. These are kind of the most tried and true methods to solve any quadratic equation. Okay, but the another reason completing the square is so important is because you end up completing the square a lot to get quadratics in what we call vertex form. You use completing the square once you get the conic sections. Getting a conic section in a standard form, so circles, hyperbolas, parabolas, ellipses. We use completing the square a lot in all of those concepts, and even more concepts, but those are really a few big ones that we're definitely going to be taking a look at. Okay, so completing the square, I kind of have a list, and I'll go ahead and take you through it, okay? So the first thing that you want to do is you want to make sure you're in standard form. Remember, the standard form of a quadratic is ax squared plus bx plus c is equal to 0. And you can see we're already in standard form here. Okay. Now your next step is to divide by your leading coefficient if it is not 1. You actually cannot complete the square if your leading coefficient is not 1. So if it's not 1, divide everything through by whatever that coefficient is. But in this case, as you can see, we have a leading coefficient of 1, so we don't have to worry about that. Don't worry, we'll take a look at another example that doesn't have a leading coefficient of 1. Once you have a leading coefficient of 1, what we want to do is we want to move the constant over. So I will be subtracting 19 from each side. And once we do that, we get x squared plus 18x. And I'm going to go ahead and leave a space here. We're going to be adding something there. Is equal to negative 19. And I'm going to leave another space there, okay? Now once we get here, this is where the completing the square starts. What we're trying to do is create a perfect square trinomial. So like a perfect square trinomial is something like this. And the reason this is a perfect square trinomial is because this would factor to x plus 3 and x plus 3, which is x plus 3 quantity squared. And this is why we complete the square, to get this right here, something similar to that, because then we can solve using square roots, which we did in the last video. Okay, now to create that perfect square, what we have to do is we have to take half of the linear coefficient. So we're going to be taking half of 18, and that gets us 9. Okay, now what we do is we take that 9 and we square it to get 81, and we add that value to each side. Because what we just did is we created a perfect square trinomial. If we were to factor that, that would factor to x plus 9 times x plus 9, which creates the nice binomial of x plus 9 quantity squared. Okay, this factors x plus 9 quantity squared. And a little tidbit of information: half of the linear coefficient is always going to be the number inside those parentheses. Okay, half of 18 was positive 9. I got a positive 9 in those parentheses. That's what we're doing. That's how we complete the square. Okay, that is why this becomes x plus 9 quantity squared, because we took half of 18, which got us 9, and we squared 9 to create the perfect square. 9 squared, which is 81. Okay, so that's how we complete the square. So I take half of 18, that gets me 9. That's going to be inside, but to add to each side, that becomes 9 squared, which is 81. And I have to add 81 to each side, because what I do to one side, I have to do to the other side to keep the equation balanced. And at negative 19 plus 81 would get me 62. And now from here, this is actually a problem just like the last video, square roots. So now, once we factored, which was x plus 9 quantity squared, we solve using square roots. Because now, as I can see, I can just take the square root of each side, and this is going to become x plus 9, because when we square root a square, that cancels, so x plus 9 is equal to plus or minus, do not forget the plus or minus, the square root of 62. And if you can simplify the square root of 62, make sure that you do so. No perfect squares going to 62, so we can't simplify that. And then our last step would simply be to subtract 9 from each side. So what this ends up becoming is x is equal to negative 9 plus or minus the square root of 62, okay? And that would end up being our final answer. If you can simplify that at all, make sure that you simplify, but we can't go any further, okay? And that's what's really nice about completing the square. We would have gotten this exact same answer with the quadratic formula, but in my personal opinion, it doesn't require as much work for most of these situations, okay? So that's what completing the square is, but let's go ahead and take a look at another example. So let's say we had something like 2x squared plus 12x minus 34 is equal to 0, okay? Remember, the first step is to make sure that everything is in standard form. It already is. Now we can't complete the square unless we have a leading coefficient of 1, and in this case we don't have a leading coefficient of 1. So what we need to do is to divide everything, each side, through by our leading coefficient. So I'm going to divide each side by our leading coefficient of 2. And what that would end up getting us is x squared plus 6x minus 17 is equal to 0. And now from here we can go ahead and move our constants over to the other side. So I'm going to go ahead and add 17 to each side. So that's going to get us x squared plus 6x. I'm going to leave a little space over here is equal to 17. Plus, I'm going to leave a little space over here as well. And this is where completing the square comes into play, okay? We're going to take half of our linear term, or linear coefficient, I should say, not linear term, the linear coefficient. So half of 6 is 3. So I know eventually, when I factor, this is going to become x plus 3 quantity squared, because half of 6 was positive 3, so x and a positive 3 plus 3. But that's not what I add to each side. I now take that 3 and I square it, and that gets me 9. So I'm adding 9 to each side. So this would eventually become x plus 3 quantity squared is equal to, that would be 26. 17 plus 9 is 26. And now, just like before, we take the square root of each side. When we square root a square, that cancels those out. So this becomes x plus 3 is equal to plus or minus the square root of 26. I can't simplify the square root of 26 at all. And what I mean by that, because some of us might be asking, if I had like the square root of 12, I can make that 4 times 3, and the square root of 4 is 2. So the square root of 12 simplifies to 2 root 3. So see if you can simplify. We can't simplify the square root of 26, okay? So our last step, subtract 3 from each side to get the final answer of x is equal to negative 3 plus or minus the square root of 26, okay? And that is completing the square. Something that a lot of, especially Algebra 1 students, seem quite daunting, really isn't all that bad, okay? It's really just kind of an algorithm. You just follow these steps, complete the process, and you get your final answer, okay? So that is completing the square. That method, remember, can be used to solve any quadratic equation, any quadratic equation. In our next video, we will be taking a look at the quadratic formula, which can also be used to solve any quadratic equation. So make sure that we stay tuned and check that out.